5.6, find rational zeros. We're going to start with the rational zero theorem. So if f of x equals, I don't like the way I wrote that if. And I'm going to write a polynomial here. So my leading coefficient I'm going to call a sub n. And so then my x will be to the nth power. And then I'm going to go plus dot, 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 all the way down to a sub 1 of x to the first power. So I won't put a 1, plus a sub 0 doesn't have an x at all. So if this polynomial has integer coefficients, so integers, negative and positive whole numbers, so I don't have like square root coefficients, I don't have anything weird. So if it has integer coefficients, then every rational zero of f has the following form. So by rational zero, we mean, well, a zero is any solution, right? If I put a zero where my f of x is, or if I'm thinking about x-intercepts, solving for x, all of that, those are our zeros. And rational would mean fractions are included. Integers, fractions, all of that. Anything I can write as a fraction would be rational. And it has the following form, p over q, where p is a factor of the leading factor of the constant term, of the constant term, a sub 0, so that's at the end, our constant, and q is a factor of the leading coefficient. In our case, for our fake polynomial, a sub n. That sounds like a lot, so we're going to look at in practice what this really does. So what it's telling me, for like example 1 here, it says we're listing all of the possible rational zeros of f using the rational zero theorem. So we're looking at a cubic polynomial. We don't have a quadratic that we can easily solve, but this theorem, this rational zero theorem, gives us some things that could be the answer, that could actually be our zeros. So p comes from the 6, and q comes from the 1 in front of the x cubed there for my leading coefficient. So p is factors of the constant term. So if I think about factors of 6, well, 1 times 6 is 6, 2 times 3 is 6, and because we're looking at integers, they could all be plus or minus. So now I have a list of factors for 6, and then the factors for 1 would just be plus or minus 1. So now I need to write those all as a fraction. So it's going to be p on top and q on the bottom. Since q is just 1, it doesn't really matter. So my p over q values will be plus or minus. 1 over 1 is just 1. 2 over 1 is just 2. I got to put all those plus or minus signs in. 3 over 1, so 3, and 6. So those are all my possible rational zeros. So it doesn't tell me which ones are the right answers, if any, but those are the possible things that could be zeros. Let's try B as well. So for B, when I'm looking at the 8, that's my factors that are P. So plus or minus 1, 2, 4, and 8. Those are all numbers that divide into 8 evenly. And then for 2, for Q, we'll have a plus or minus 1, plus or minus 2. So now I'm going to write my P over Q's. So first I'm going to take all of the numbers for P, 1, 2, 4, and 8, and divide them over the 1. So that's not going to change them. 2, 4, and 8. Okay, and now I'm going to take all these values of P and match them up with the other value that I have for Q, which is plus or minus 2. So plus or minus 1 over 2, so that'll be plus or minus 1/2. Plus or minus 2 over 2 would just be 1. I already have that. 4 over 2 is 2, I already have that, and 8 over 2 is 4. So sometimes when you go to write down other values, you'll realize that they're really on that list. So like, let's just write those down just so you get it. So I have 1 over 2, I could have 2 over 2, 4 over 2, 8 over 2, except all of these values reduced to numbers already on my list, so I don't have to write them down. And again, these are not my zeros, they are possible zeros. To find the actual zeros of a function, we have to test them using synthetic division. So let's remember, if the remainder is 0, it divides evenly, it's a factor, it is a 0. So that's how we check it. So remember that remainder theorem from yesterday. We were looking more in terms, remember we wrote down that binomial like x minus k, k was a factor. X minus k was a factor if it equaled 0. So for example 2, we're asked to find all real zeros of a polynomial. So I again need to look at those p's and q's. So let's see, p is going to be plus or minus 1. Let's see, 5 and 7 divide into 35. So plus or minus 5, plus or minus 7, plus or minus 35. And then my leading coefficient is just a 1. So q is going to equal a plus or minus 1. And so my p over q values are plus or minus 1, 5, 7, and 35. And so now I'm just going to have to check these numbers and I'm going to see, are any of them actual zeros? So my goal, like we did with our notes yesterday, is going to be to find a depressed equation. So I want to find a 0, and then I want to work with a depressed equation, which will then be a quadratic. And I know I can factor, I can work with quadratics. So that's my goal. So I usually just start with 1. So I'm going to start with 1. Let's see. My coefficients are 1, negative 5, 7, negative 35. Remember, we have to watch and make sure there's no placeholder zeros we have to put in there, that they are perfectly in descending order. We go through and work it out. Remember, we bring down the first number. So let's write some notes. We bring down, and then we multiply, and then we put it over here, and then we're going to add. So I just want to write those steps in again, and we just repeat that pattern. So 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is negative 4. Add, I get 3. 3 times 1 is 3. I add, and I get a negative 32. So this is definitely not a 0. So I'm going to try negative 1. 1, negative 5, 7, negative 35. So 1, negative 1, negative 6, 6, 13. You start to get pretty fast at this. So both times I did not get a 0. So they are not factors. Remainder is not 0. So let's try the next one. I have a good feeling about this. Let's try 5. So I'm going to try 5. So let's see, 1 times 5 is 5, and then I add and I get a 0. 0 times 5 is 0. I add and get a 7. 7 times 5 is 35. I add and get a 0. So yes. So this means, because I used 5, this means x minus 5 is a factor. And it means that 5 is a 0. Okay? So x minus 5 is a factor, and x equals 5 gives me a 0. So 5 is a 0. So what I'm working with right here, the 107, that gives me a depressed equation. Since my original was cubed, now this depressed equation will be squared. So now I have x squared plus 0x plus 7, which is just really x squared plus 7. And I am trying to find all real zeros, so that means I'm making it equal to 0 and I'm solving. So I'm going to solve this by subtracting 7 and taking the square root. I recognize that I can't factor, and I do not need to do the quadratic formula. So I'm going to take the square root. I have no idea. I think I just keep bumping the screen because I'm tired. So square root on both sides. Normally would say, oh, can't take the square root of -7, but now we're going to say it's the square root of 7 times I. On the other side, I have absolute value of x. So this means x is going to equal plus or minus the square root of 7i. So my zeros are, so now this is where it's tricky. We can't remember that, we can't forget about that 5 that we already had. When we used 5, we got a remainder of 0. And then we have the square root of 7 times I. I don't know why it's still freaking out and doing this. And we have the negative square root of 7 times I. So you've got to always list those zeros, even those ones that you kind of use to get that depressed equation that you might have forgotten about. So you can see now today, you can kind of put it all together like, oh my gosh, we're going to be able to solve these really big polynomials now. We have this tool called synthetic division. We can kind of hunt and try to find some of these zeros. So lots of stuff going on here. So on example 3, we're going to start it the same way. We're always going to start with our P's and Q's. One thing I notice right away, my coefficients are 9, 3, 30, 6, 12. I can reduce all of that if I think about finding a 0. If I have 0 equal to all of this, I can factor out that 3, and I don't lose any solutions that way. And I really want to have smaller numbers for P's and Q's anyway, because then I'll have less numbers to guess when I'm doing my possible rational zeros. So I'm going to divide everything or multiply everything by a third. So then I'll have 0 equals 3x to the 4th plus x cubed minus 10x squared. Smaller numbers to work with for synthetic 2 is nice. Plus 2x plus 4. So P's and Q's, remember P comes from my constant term, so P is going to be plus or minus 1, 2, and 4. I forgot my plus or minus signs. So that's a lot better than looking at factors of 12. And let's see, 3 would be plus or minus 1 or 3. So when I write these as P over Q, I have plus or minus 1 and 2 and 4. But then I could have 1/3 and 2/3 and 4/3. And sometimes the fraction answers will be the right ones, but I usually try to start with integers. It's just easier. I don't want to start guessing 1/3 right away. So it's a lot faster to go through these integers. So I'm going to use the 1, and then I'm going to use my equation with the lower values, 3, 1, -10, 2, and 4. Fourth degree this time, huh? So let's see. What's left? Bring down your 3, multiply, write it underneath, add it, multiply, and then add. Oh, and we got a 0 on our first try. That never happens. So now we are going to work with the depressed equation. So we're going to try to forget. I have no idea why I put an E there. So now we're going to forget about all that stuff we already wrote down. We're just going to focus on this depressed equation. So now we're going to work with 3x. Let's see, we had fourth, so now we're down to third power. So 3x cubed plus 4x squared minus 6x minus 4. So this is what we're working with now. And our P over Q is the same. actually, because P and Q are the same. But sometimes that'll be different. So we need to try another value. I usually start because I got 1 gave me a 0. It doesn't mean that 1 couldn't be a solution twice. That would be a multiplicity, so I'm going to just try it again. And remember, we're using 3, 4, negative 6, negative 4 now. We're not going back to the original. So let's go ahead and check this. So that's not a solution, but notice I'm not erasing it. I'm just leaving it there. Now I'm going to try negative 1. I just try to be very methodical. If I don't erase, then I have that work to look back on later if I'm curious. And that one was not a solution either. So let's see, I tried 1 and negative 1. Now I'm going to try 2. So I really just go right through that list in order. And I don't erase anything. These take up a lot of space. 28. Nope, this one's not going to work either. How about negative 2? What's nice is if you don't erase, then you can always look back and try to find a mistake. So let's see, 3, running out of space here. Negative 6, let's see, this is negative 2, 4, negative 2, 4, 0. Finally. So now we have a new depressed equation. So we have, let's see, we started out with an x cubed, so now we have an x squared. So now we have 3x squared minus 2x minus 2. We're finding zeros, so we're going to make it equal to 0. And let's see, I wonder if it's factorable. So I'm going to find my discriminant really quick. I can't think of how it'd be factorable right away, but my discriminant is the b squared, so negative 2 squared minus 4 times 3 times negative 2. So remember, when I work out my discriminant, if I get 0 or a perfect square, it's factorable. So 4 minus, let's see, this will end up being plus 12 times 2 is 24, so that's 28. So it is not factorable because I got a 28. If it was 36, it would be factorable. If it was 16, it'd be factorable. A perfect square or 0 would mean it was factorable, but it's not. So I need to do my quadratic formula. So b would be 2 plus or minus. So that part inside the square root now I already know is 28 because that's my discriminant. And then it's all over 2 times a, so 2 times 3. I can't really complete the square on this one because it has a coefficient of 3, a leading coefficient of 3. I want to break down the square root of 28 and call it square root of 4, square root of 7. 2 times 3 is 6. So I've got 2 plus or minus 2 square roots of 7 all over 6, and I can reduce all of these. So let's see, this is going to be 1 plus or minus the square root of 7 over, oh, it's not 6 anymore, now it's a 3. And now that I've finished solving, I can list out my zeros. So my zeros were, let's see, I had a 0 that was 1 and a 0 that was negative 2. So let's go ahead and list those. So zeros were 1, negative 2, and then 1 plus the square root of 7 over 3, and 1 minus the square root of 7 over 3. So we had 4 answers on that one. Last one is a volume problem. A prism has a square base. So let's draw a prism with a square base would look, well, not like that. Let's make it prettier. And I guess I should draw maybe the square base part first. It's probably the least efficient way of drawing a square pyramid. And the height is 5 feet longer than each side of the base. So let's call the side of the base x, and it's a square, so they're both x. And then the height is 5 feet longer, so that will be x plus 5. The volume is 28 cubic feet. What is the height? So let's think about our equation for volume. Volume equals length times width times height. So our volume is 28, and our length is x, and our width is x, and our height is x plus h, or x plus 5. So we need to go ahead and work this out and make it a polynomial. So this would be 28 equals x squared times x plus 5. Then we would distribute that. And then to solve, we'd have to subtract the 28 on both sides. And I'm still showing plus or minus on both sides because I want full credit for my teacher. Now, because it is a cubic, we really have no way of solving this. I might have a hope if there was 4 terms, I could factor by grouping. But the first term is x cubed, second one is x, so I'm going to have to do synthetic. So at least my, when I'm thinking about p's and q's, my q is just 1, so that's going to be easy. P would be, let's see, all those factors of 28. So p over q will be plus or minus 1, 2, 4, 7, 14, and 28. So I'm going to start with 1. I just always do it. It just works for me. Some people like jumping around. So my x cubed is 1. I have no x squared, so I'm going to have to put, oh, I do have an x squared, don't I? I messed it up above. Let's fix that. So x squared times x was an x cubed. X squared times 5 was a 5x squared. So I have a 1 and a 5, but I have no x term. So I'm going to put a 0, and then my constant's a negative 28. Now I've got to go through and check this. Definitely not a winner. So let's try negative 1. And remember, we have that placeholder 0 in. I think I need to write smaller so I can fit more of these in. Still not a solution. So let's try 2. All of a sudden, my pen's not writing again. There we go. Oh, this one looks good, 28. All right, so we got a 0. So now we want to look at what's left. And we have x squared, let's see, plus 7x plus 14. Remember, we started out with cubes, so now this is an x squared. Remember, we're solving this equal to 0. I could do completing the square, except my middle term's odd, so taking half of 7 and squaring it's going to be a fraction. I don't really want to do that. And I can't factor it, so I'm going to go straight to the quadratic formula. So x equals negative 7 plus or minus 7 squared minus 4 times 1 times 14 all over 2 times 1. So let's see, x is negative 7 plus or minus 49 minus 4 times 14 is 56 all over 2. And 49 minus 56 is negative 7 all over 2. So there is no real solution, which I could still get an answer, but I am looking for a real life prism. So imaginary numbers will not work for this. They will not work for a prism. And so x equals, that only 0 we found was a 2, so x must just equal 2. So now let's think about that prism again, and I'm going to draw 2 squares and just connect them this time. So we know the base was x and x, so we have a 2 and a 2. The height was x plus 5. So 2 plus 5 would be 7. So the height is 7. And this concludes our 5-6 notes.